Yeah, good evening, dear participants. Today, second day of the FDP. So today we have two sessions. So first session start from 6 to 6 o'clock, 6 to 7:30 p.m. And the second section immediately start from 7:30 to 9 p.m. So today up to 9 only. So yesterday it went up to 9:30. So due to the inaugural section. Yeah, first session, the Associate Professor Venkkanna sir, NIT Warangal. So he take the first session on the topic machine learning fundamentals in security applications. So I would like to introduce about the Venkkanna sir. So Dr. Venkkanna sir obtained his PhD from the National Institute of Technology, Tiruchirappalli. In 2015, he has been in the teaching profession since 2005 and is currently serving as Associate Professor in the Department of Computer Science and Engineering, NIT Warangal. So prior to this, he held the position of Associate Professor at IIIT DM, Kurnool from August to November 2023 and served as an Assistant Professor at IIIT Naya Raipur from 2016 to 2023 with over 16 years of teaching and research experience. Dr. Venkkanna sir has also held several key administrative roles. He served as Associate Dean Student Affairs, Student Welfare at IIIT, so DM Kurnool, and as Professor in charge of the Department of CSE and the Student Activity Center, SAC, at IIIT NR. His research interests span a broad range of topics, including the IoT, industrial IoT, software-defined networks, network security, and security and privacy in AI models and autonomous vehicle systems. So Dr. Venkkanna has authored over 95 plus research publications, including articles in IEEE transactions and reputed journals. He has successfully supervised 3 PhD scholars and is currently guiding 4 doctoral students. So working on security challenges in IoT, SDN and data plane programmatical. So his work has been recognized with the Best Paper Awards at IEEE ANTS 2019 and the 27th IEEE Symposium on Computers and Communications, a rank B conference. He has elevated to this status of IEEE senior member in August 2021. As principal investigator, he completed the Tribe Connect project funded by the Ministry of Electronics and Information Technology, Government of India. He is currently serving as co-principal investigator on 2 ongoing research projects. So one on security in autonomous vehicles, so funded by TCIOE DOT, and another project is 5G network management, so funded by the IIIT Comet Foundation under NMICPS DST Government of India. So additionally, he holds 5 granted Indian patents and has 4 more patents published. Yeah, thank you, sir, for your great profile.
Thank you.
Yeah,
thank you, sir.
Which will help to our participants. Dear participants, please focusing on the sessions. For more information, you can also contact the Venkkanna sir by using this website www.venkkannaU.com for any queries or any further references. Yeah, thank you, my dear participants.
Thank you, sir.
Thank you, sir. You can proceed, sir.
Thank you. Thank you, sir. First of all, I would like to thank you, Professor Venkatramulu, sir, for inviting me to deliver a lecture in this ATAL-FDP program. And also I'm thanking the KITS management who invited me to deliver this lecture also. Let me share the screen, sir, for a while.
Yeah. Thank you, sir. Thank you. You can.
Once one minute. Yes. Sir, is my screen is visible, sir?
Yeah, visible.
1 minute. I hope. I think it is visible, I guess. Yes, sir.
Yeah, yeah.
Yes, sir. Thank you, sir. Thank you for your nice introduction. Okay, and if anyone have any doubt, also please interrupt me during the session so that I can answer. Uh, uh, I'm going to deliver a talk on IoT security solutions using a machine learning approaches. Two students already graduated in this particular research topic, so that I'm trying to cover from the basics to the within a time limit before 7:30 p.m. And even I have one more session also. If anything is missing, I'll try to cover that particular leftover topic in that session. And my 1.5 hour session is going to cover broadly into these 4 subtopics. First, I'm going to talk introduction related to IoT and what are the various applications used in IoT. Then then once it is completed, I'm going to jump into what are the various security challenges currently IoT is facing, because it is a emerging topic. Many security issues are coming up. And from the broader security solution, we have identified a specific research problem. On that, we provided a couple of solutions that I am going to talk. And most of them are the research community, means some of them are doing PhD, some of them are faculty guiding the PhD. Obviously, they expect what could be the future research direction in this particular domain. That also I'm going to talk. But I request everyone so that if anyone have any doubt, they can interrupt me. Now, before talking to the IoT security solution, first I would like to introduce, if you want to design an IoT prototype, what we have to do. Now, these are the basic 5 elements for any IoT prototype designing. One is for thing or device. Second one is a gateway. Third one is a cloud. Fourth one, some sort of analytics you are going to do. And fifth one is to use the user interface. Now, most of the people, they confuse by using the word like a sensor and IoT device. Okay. Is anyone know the difference between these two? Is both are same? Anyone have a doubt? Anyone can answer this question? What is the difference between the sensor and IoT device? Okay, fine. But in general, the sensor do a specific functionality and IoT also do specific functionality. Both are totally different. And sensor is a part of IoT device. The basic job of sensor to sense the physical parameter and push that physical parameter to the internet or to the cloud. Now, whenever you want to make any IoT prototype, first you have to make a IoT device. Okay, that is a very important. Now, whenever you are making IoT device, you need to remember 3 components you need to keep in mind. First one is a kind of sensor. Now, second one is some kind of microcontroller, or sometimes we call mini computer. We may use it. Okay. Now, third one, the very important is called communication module. Okay, communication module. These are the 3 components you need to make it. The sensor depend upon the application you are designing. For example, I want to monitor temperature of the room. You can use a temperature sensor. Or you want to measure the moisture level of the soil, you need to use the soil moisture sensor. Like many physical parameter, you can sense it. Those physical parameter you can collect. Now, sensor job is to sense the physical parameter and convert that physical parameter into an electrical signal. Okay. Okay. This electrical signal is collected by your microcontroller. Example of the microcontroller, most of the time we use is Arduino. And sometimes we use this Node MCU nowadays because it has an inbuilt communication module. It has an inbuilt communication module such as Wi-Fi. It has an inbuilt communication module. And certain larger applications we use as Raspberry Pi also. It has many inbuilt communication module. One of the popular inbuilt communication module is a Bluetooth, and as well also uses Wi-Fi. Now, like you can take based on your specific application, you can take more than one sensor. Those sensors can be integrated with a microcontroller. This microcontroller job is to collect this electrical signal and communicate to the outside, give it to the communication module. Now, basically what will happen, this electrical signal, whatever the electrical signal you're sensing from the physical parameter, now it collects a lot of data also, but I can write a small program, how many parameters, how many values I need to collect. That program could be deployed in a microcontroller or mini computer such as the program, the data need to be collected. And certain data can be stored temporarily into your microcontroller. But the basic definition of IoT, things need to be connected to the internet, but these data need to be pushed to the outside the world. Means outside the world means the device which is connected to the internet. Okay. But this side you have a communication module, but your microcontroller just collected the data. That's why third important component in any IoT device is called communication module. You are going to interface one of the communication module called Wi-Fi. So that Wi-Fi can transport your data from your microcontroller to your next hub device, such as Wi-Fi access point or router. Now, these three basic components you need to integrate and call it as an IoT device. Whatever the prototype you're designing, you just see that whether these three are present or not. Once the data is collected by Wi-Fi device, that can be pushed to a gateway. The second important component of any IoT architecture is called gateway. Gateway basically used when you are designing more than one IoT device. Every device can send the data over the wireless communication module. One of the wireless communication module is a Wi-Fi. Suppose let us take in your room, you deployed 10 IoT devices. These all 10 IoT devices send the Wi-Fi signal, but these all Wi-Fi signal could be collected by using one more gateway. This gateway, you can make it as a Raspberry Pi also, so that it has the Wi-Fi communication module and your node MCU or your IoT device also having a wireless communication. As both are having operating in a wireless communication module, whatever your IoT device is sensing or sending can be received by your Raspberry Pi or your gateway. That is the first job of the gateway. Now, second job is the interface which you are communicating here. It is in a wireless communication module. The other side of the interface, it is in a wired communication module. Other side in a wired communication. There is a necessity for the protocol data conversion from wireless to wired that can be done by your gateway. Now, once the data is reaching to the gateway, via gateway, the data can be stored into a cloud. Now, we are storing the data into a cloud for basically two reasons. The first reason, when the data stored into a cloud, if you want unlimited data is available in the cloud. That is the first reason why we are storing data into a cloud. Now, second reason, by storing the data into a cloud, you can access from anywhere, anytime. These are the two primary reasons why we are storing data into a cloud. Now, this is the third component of any IoT prototype design. Once the data stored into a cloud, you are going to collect in a second or in a minute the large volume of data. But what I will do with this large volume of the data? I need to analyze it and generate some sort of insights. That's why you may use some kind of machine learning algorithm or deep learning algorithm based on the data, based on the application. You are going to develop your own machine learning model. And whatever the data you are collecting on real time, feed it to a machine learning model or deep learning model for appropriate insights. For example, you have certain smart CCTV camera It collects a lot of video input data and feed it to your machine learning model or deep learning model. Now that model can perfectly say that, yes, the entered person is actual person of the house, or going to enter the person is not authorized person to enter the house. Now some sites of insights generated means allow, not allow. There is a kind of insights. But these insights can be generated by using a standard machine learning or deep learning algorithm. Now, sometimes these insights need to be displayed on some sort of user interface. I would like to see how many times the unknown person tried to enter in my house. I want some information. But that information, if you want to display, some sort of interface is required. That is a called mobile app or web interface, like and so on. Means if I want to design any IoT prototype, make sure that these 5 components present or not. Any one of the component is present also, we cannot treat this as a basic IoT prototype. Now, this today's topic, the security issues related to IoT. Yes. Now, whenever the data is sensing from a device to display on the user interface, this entire communication is going to happen on the public channel, not the private communication medium. Please remember. Now, whenever the data is transmitting over the public channel, there are a lot of security issues present here. It is simply like, unless you are present in your home, because home is your private space, so that less security threat will be available. But once you walk outside the house, when you are roaming on the road or you are moving on the corridors, etc., you have a lot of security threat because you are accessing or somebody can access publicly from outside using a public channel. Similar manner, your sensitive data is going to be transmitted over the public network, then indirectly it has a lot of security issues. That's going to be discussed in a subsequent slides. As you are aware of, most of them are offering IoT course and some of them even teaching IoT courses. They know very well. IoT has wide variety of application. One of the wide variety of application like a cooling management system in a particular room or in a smart city application or mobile healthcare application or and certain agriculture applications used IoT solutions. Not only them, even right now, most of the IoT solutions are even used for autonomous vehicles because these also one kind of IoT category because your autonomous vehicle is connected to the internet. Over the internet, this vehicle is maybe drive on the path and send because this autonomous vehicle also having a lot of sensors. By sensing information, it is feed it to a machine learning model, take the appropriate decision. Like similar manner, the many IoT applications are coming up nowadays. That's why I can say that this IoT technology is one kind of disruptive technology. Just I brought this picture from the Google source to show that the wide applicability of IoT is increasing day by day. By 2028 in India also, most of applications are designed by using a disruptive technology called IoT. Fine, one side of the coin, IoT is very good. It is used or it is solved the many of our problems. But if I see other side of the coin, now these sensors are sensing information. But the question, what are they collecting that is completely unknown to you? What kind of information they are collecting? Right? Because you may collecting only temperature of your room, but from the temperature, I can get a lot of indirect meaning so that indirect meanings may leads to a privacy issue or security issue of a particular house. And who all are they sharing this particular data? That is also completely unknown. Your data, after sensing, the data is pushed over the internet by using public channel, so that who all are sharing that particular data is completely unknown. And third important, the security issue is that how long the data is available for life. Generally, certain information can be remembered and erased, but the sensor information, once it is stored, but how long the data can keeping with you. Okay, by keeping this particular data, are you able to infer any indirect meanings out of it? That's what the major security threats of IoT is, these three things. As you've seen, any disruptive technology, how it is going to be evolved, and what kind of security issues also mentioned, that is through the Gartner slide. And next couple of minutes, I'm going to talk what are the different security attacks happen, means IoT security attacks happen recently or past 5 years that I'm going to show you. You can see from this particular slide, it is mentioned in the newspaper, DDoS attack that happen on the IoT system that disrupt the entire IoT setup which present in certain industry. That you can see here, that is a called power grid company, which uses a lot of sensory technology. By malfunctioning certain sensor, entire power grid is collapsed, so that economy of that particular company or functionality of that particular company got stopped for a while. It leads to a financial loss of that. Even many of the IoT solutions which we are seeing or listening in related to healthcare application, one of the popular healthcare application related to IoT is called pacemaker. Generally, this pacemaker embedded into a human body. That major objective of this pacemaker to pump the blood in a regulatory manner, but it also involved a lot of sensors in it. But generally, the sensors are communicating in a wireless channel. Now, some of the attacker can present nearby your sensor and disseminate a lot of or control the sensor present in your pacemaker, so that you can increase the blood pumping rate a little bit high. That leads to a heart attack, then that leads to a death of human person. Like many incidents nowadays reported, this type of attacks happen when you use healthcare based IoT solutions. Not only security solution, as I just now mentioned in my previous slide, IoT means similar principle of IoT is called autonomous vehicles, which also having a sensors. Now, one of the sensor in any autonomous vehicle called GPS sensor. Okay. Now, the signal of the GPS data, if it is a compromised, what will happen? Instead of moving towards this direction, vehicle may move towards the other direction. So that by moving to other direction, there is a chance it may hit or crash the vehicle. So that leads to a human loss. Many autonomous vehicles nowadays is compromised or performed attack. That also we are reporting into current security threats. Right now, it is very clear the IoT is one side is having a lot of advantage, but other side posing a lot of security risk to individual. Like you've seen pacemaker, it is a good which regulate my entire blood pumping level system. But as present, some of the sensor present in this, that if it is a compromised, it may pose risk to the individual. And security of the IoT is going to be challenging because the solution present for the application one, suppose let us take healthcare application or some industrial application related to IoT. Okay. The security solution which I am proposing here might not same here, because the physical parameter used or sensor type used here different and here also different. means completely a different security solutions are required. That's why providing independent or providing individual security solution for the particular application is going to be challenging today, even tomorrow for that. Then another challenge to provide the security, whatever the devices is manufactured by various companies, not only 1, 2 companies across the globe. And the government role is very limited in this particular thing. And ISP role also very limited to provide the security. Suppose whereas network security, ISPs are going to play important role and prevent certain security attacks which is happening across the network. But when it comes to IoT, ISPs are providing a limited role that is creating a challenge. Now, another side of the IoT security, in order to make my security algorithm run, it required a lot of resources. But whereas IoT solutions having a limited resources, that is also one of the security challenge. There is also one of the challenge to implement a robust security in IoT. Now, this particular slide is clearly differentiating. You may have a doubt, sir, the many security solutions are available in the internet. Can't be applicable same sort of security solution in IoT? I say no, because you can find out from this particular slide. In IT security, means internet security, many only few networking devices are part of it. Few means, for example, you have a computer, laptop, or mobile devices, maybe another 3, 4 electronic gadgets which are part of internet. Using them only we are communicating over the internet. But when you come to IoT, now healthcare application having a different device and industrial IoT applications are different device. Means what I want to say that the variety of heterogeneous devices are part of this IoT. Means here you have a little homogeneous, whereas in IoT, lot of heterogeneous devices are part of it. The second difference is that then internet security can be protected by using a constrained environment. Means, for example, you take your campus network. I want to protect campus network. Just simply deploy a firewall to protect your campus network. Most of the security solutions can be mitigated by using your firewall because it is a constrained environment. But whereas IoT, it is not working in a constrained environment. Most of the application it is deployed in outdoor environment so that your IoT devices are communicating wirelessly. If any device present in the communication mode, they can capture the wireless signal and some sort of inference can be taken place. Then another challenge to provide the security or good advantage provide the security in internet is resources are many. Means suppose you want to run some sophisticated asymmetric key algorithm, can easily run on your computer because computer is connected to the internet and computer having a good amount of CPU, computer having a memory, computer having secondary storage and good IO devices. But whereas here you have a limited devices. Suppose if you take Node MCU, it has a small processor and it has very limited capacity of memory, so that I cannot run a sophisticated machine learning model or sophisticated security solution here to provide the security. And suppose you protected your network by using a firewall. Now breaching the firewall or rewrite the firewall rule with respect to internet security is a little challenging. Firewalls are manufactured by couple of industries in the globe. They use their own programming language to function those hardware devices. But if you want to breach it or you want to provide certain attacks, first you should understand what language they have used and what kind of compilers they are using, that is completely unknown to the third person. But security breaching with respect to IoT is very easy because your communication is taking place in a wirelessly, so that and it is not going to be used any sophisticated algorithm or sophisticated programs to provide the security with respect to IoT as of now. So that what I want to say that from the four different parameter comparison, providing the security for the IoT is going to be a challenging issue, no doubt in that. That's why my particular talk emphasizing on that. Those who are interested, they can easily pursue or start working towards the security issues with respect to IoT. Now, objective of the lecture, how can we build a secure IoT devices to solve or to mitigate new legislative challenges? Means day by day, today you provided one sort of solution for IoT environment that may not feasible tomorrow, because tomorrow your IoT attack is going to happen differently. That's why whatever the security solution you are going to provide, how can amicably used for a long run and with many variety of applications, that is a completely unknown. How might we tackle IoT security problem? That is also another inbuilt, which I have explained with respect to first parameter. What are the new intellectual challenges day by day? Now, today you provided the security solution for something, but tomorrow some sort of attack is coming that the ready-made solution is not available. But with existing solution, how can we mitigate the upcoming attacks or new attacks which are going to be emerge? That we are going to see that. And as you know that most of the IoT attacks will happen due to malwares, because I'm not going to cover much. Malware means simple a malicious program which deployed over the IoT device, which can lead to some sort of DOS attack. One of the malware attack which you are seeing, which if you Google it in internet, which happened in 2016, that is called Mirai botnet attack. What exactly it happened? The attacker take the vulnerabilities in one of the IoT device present in the network. Using that particular device is installed some malicious program. Using that particular malicious program, he is able to control the remaining devices part of the IoT network. So that slowly, many of the devices is in the control of the attacker. Means this kind of attack is some sort of network-based attack. Then what happens once these all devices are under the control of the attacker, there is a chance the data may be whatever it is collected from the devices can be redirected to the attacker node, so that later he can analyze and get some sort of inferences from the IoT device. Suppose you connected IoT devices related to healthcare applications. Now your healthcare application means your vital parameters are very private to you, but slowly I can infer what exactly it is happening. These anyway, some sort of IoT vulnerabilities. For in the interest of time, I am just skipping because we should focus more on to the. Okay, now what I want to say that this most of the IoT attacks nowadays, they started providing using a machine learning algorithms. But when you want to develop any machine learning algorithms, you require certain data sets. These are the popular data sets as of now available, but you may have few other data sets also. But what we come across from the various research papers and the standard research papers used data set name I have mentioned. But each and every data set specifically focused on some sort of attack, not generalized attack. Suppose IoT 23 is capture the Mirai attack, Tori attack, like and so on. Whereas the CIOT 23, it provides the comprehensive of multiple IoT attacks, such as DDoS attack. Okay, maybe some attack also it is mentioned in this particular thing. Like every data set capture the attack rate and attack type is different. Based on your security solution, you can pick up any one of the data set. Right. Now, in order to provide any security solutions, either using a machine learning or traditional cryptography algorithms, first you should understand, or if you want to provide a security solution by yourself, first and foremost thing, you should design some sort of attack methodology by yours. Then prove that attack happens in such a way so that really it is going to be impact on the IoT network or IoT data. Now, if this attack happen, what kind of solution it is going to be used, that need to be discussed in your research paper. Now, few of the attack scenarios I brought, you can see this was a paper published by some of the author, not me. Now, in this particular paper, what he proposed, what he mentioned, or how he has mentioned, how can you perform some attack on IoT network. For example, this particular cycle, bicycle, in some of the foreign university, they uses the cycles to move around the campus. That cycles are called smart bicycles. Smart bicycles means every cycle is connected to the internet using some sort of QR code. Just if you want to use the cycle, just scan the QR code, get the details of the cycle, or enter or submit your details towards that particular app. That information reaches to a server. Now server verifies that particular details, prove that this particular student belongs to our campus and is authorized to use this particular cycle. Suppose once the data is reached to a server, it is going to be verified. That's what happened. But what attack scenario this particular author is created that? Now generally you are using a QR code. Now every QR code, when you scan it, you will get some sort of URL. Now this URL, using this particular URL, you can create a entry or you can fill the entry into a web server. Now what exactly the attacker did it? Now instead of, suppose I scanned the information related to cycle 1, capture that particular URL and submit with another unique ID 970.283. He extract the information which is related to this and cloned same information and submit to a central server so that you got the access of another 2 cycle, even though you are not an authorized person to use these particular cycles. Now, this is one kind of attacker, one kind of attack methodology created in this particular paper and performed attack so that your what attack happened here, unauthorized way, certain cycles are used. That is also one sort of security breach which presented in this paper. Now, second sort of IoT attack scenario, which is mentioned in another research paper. Generally, when any smart home IoT application, the smart home IoT applications generate the data. That generate the data means that particular application, whatever the data generated, that particular generated data using a specific port, you are going to push the data to a public repositories, which is part of the internet. Specific port. For example, you are communicating to a web server using a port number 80. Because it is a web service is a fixed port number called 80. Okay, na? Similar manner, what exactly this particular researcher did in this paper, there is a software called Avesta Wi-Fi Inspector. This is the proprietary software, can be installed in your laptop and scan what are the different ports available to communicate it. Once the port is open or available to communicate, the attacker can perform or can launch the attack using available ports. Means either you inject wrong information to the device or collect the right information from the source of the device. By collecting this particular data,
Your private information is going to be known to the attacker, first thing. Second thing, I can easily scan and find out what are the different ports available. If I know which port is open, I can easily perform some sort of attacks or to collect certain sensitive information. This means using Avesta Wi-Fi inspector is try to collect the data and do that. This now he has mentioned in his paper, these are the various IoT devices can easily scannable by using a proprietary software called Avesta Wi-Fi inspector. Like in the interest of time, I am skipping. Now, means what I want to say that my part 3 of presentation, IoT security issue is going to be very serious today and is going to be serious issue for next few years, because till date IoT is not widely applicable in everywhere in the globe. In future, no doubt, IoT is going to be applicable everywhere. Now, sensor job is to sense the data and communicate to outside the world. But whenever the data is communicating over the public channel, there are a lot of security issues. One of the primary security issues which we focused during past 5-6 years, the network-based attacks are going to be increased time to time. But how to detect the network-based attacks using efficient method? Then many solutions are proposed by the various authors. They mentioned that AI is one of the technique to find out any network-based attacks happening on IoT. Fine. But in existing network-based attacks, most of the case people use a signature in the sense. Now, priorly, you are going to know what is the attack pattern of the attacker. But if it is known, signature I am going to collect, I'm going to detect attack is happening. But in the current scenario, whatever the attack is going to happen, pattern or signature type is completely unknown. So that whatever the rule-based algorithm you have written, that rule-based algorithm cannot be applicable here. So that people have stayed, that's why I mentioned here, traditional cyber defenses relied on predominantly on signature-based, because signature might not known dynamically. So that, and some of the heuristic rules, set of rules are mentioned, but these rules are applicable and valid when the attack pattern is same like previous, but in real scenario might not. So that AI-based solutions are only thing. When you use AI algorithm, what is advantage is that, okay, it can adopt. Next slide, you can see that when you use AI solutions, it can easily find out the network traffic to detect the unusual patterns. Means your IoT traffic rate is increasing or decreasing, or what sequence of packet you're sending one by one, that all patterns can easily analyze and find out or find the dynamics of the network by using some sort of machine learning algorithm and find it. That's why, means as you have a lot of dynamic finding, that's why you can going to use machine learning algorithm, and some sort of behavior analysis also can be done with help of AI, means various machine learning algorithms. Then machine learning algorithms are ability to learn without being explicitly programmed. This is one of the advantage. When you use signature based methods, you should priorly program it. What if this value belongs to X, this value belongs to Y, then you take appropriate decision. Such sort of rules priorly mention it, but that are not feasible in the dynamics of the network. That's why you should have the system where you have a ability to learn without being explicitly programmed. And these machine learning algorithms are inherently distributed. That is another advantage why we go for the machine learning models, because your model can be trained on X device, Y device, or Z device that can be learned from these XYZ models and can easily share the knowledge, share the model weights. Using that particular model weights can easily detect it. That's what the can. And using AI model, you can easily optimize the performance. Now, as I said, we worked on the few security solution which is related to IoT. Just here, for understanding purpose, I provided the IoT architecture figure, which is mentioned in my second slide. Like devices are part of it. Next one, you have a gateway. Now, after gateway, you are connected to the internet. Now, once it is connected to the internet, over the internet, you have some sort of cloud which can store the data. From the cloud, you can use some sort of mobile phone to access the information. Those 5 components, but 2 components we assumed that it is not essential, because in this particular attacks, we focused only on network-based attacks. That's why we are not focused on the data transmission or data storage. That's why these 2 elements, for time being, it is unknown area for us. Okay. Now, as we know that the devices are things which can generate the data. Now, generated the data will be pushed to a gateway. Gateway push via switch to the internet. There is a common phenomenon. When the data is transmitting like this, what will happen? What our research is specifically focused. Now, device D1, device D2, device D3 are generating their own traffic and push it to a gateway. But gateway, what is doing? Just take the data from one interface, forwarding the data to another interface. Is not analyzing, yes, is this data which is generated is from which type of IoT traffic, or it is generating from which type of IoT device. This analysis was lagging with respect to gateway, because as of now, from the literature, what we found, gateway is just like a dumb device. Take the data from one hand and give it to another hand. Now, because of that, lot of network-based attacks are going to happen. Now, immediately it came to our mind, whatever the data generated by this IoT device, can it be analyzed and take appropriate decisions, whether need to be forwarded further or dropped further. But you have a doubt, sir, IoT traffic can be so dynamic. How will you able to analyze the traffic? Dynamic in the sense, the traffic pattern 1 might not same to the traffic pattern 2, like traffic pattern 2 might not same to the traffic pattern 3, like and so on. Means you have a wide variety of traffic is going to be generated. But how do we distinguish? That's why I said in my previous slide, we have developed a machine learning model which really useful to the IoT data analysis. Then using that, we will be able to identify, yes, this particular IoT traffic is attack traffic, or this particular IoT traffic is a benign traffic. And second sort of machine learning or deep learning model we have developed. Yes, this particular data is generating from the healthcare device, or this type of IoT traffic is generating from certain smart home device, so that I can prioritize the traffic. If healthcare device is going to generate a lot of sensitive data, if I'm able to identify source of data generation, I can easily prioritize my traffic. That's why that first problem statement, we worked on that. And second problem statement, what we said, there is a lot of big authentication issue, because IoT devices are going to communicate over the wireless channel. Okay, when they're communicating with a wireless channel, lot of unauthorized person can access your information. How do we prevent unauthorized access of IoT device? That's what the research question 2, which we formulated. Later research question 3, as we aware, whenever we want to talk to internet, the first and foremost job is to resolving the DNS query. Then only you will able to get the IP address of your domain. Right. What we observed in the literature, few solutions are trying to attempt the DNS attack in IoT environment, but most of the solutions are not tested in a real scenario or not provided the solution where exactly mitigating the DNS attacks. That's why thought research question what we formulated. How do we identify this attack is a DNS attack? So that once it is identified, how do we mitigate it? So that in future, the same device should not perform the DNS attack one more time. How do we found that is a thought research question we formulated. Now, fourth one, as we know that, yes, you are able to identify what attack it is. Okay, but can you find a solution? Is this attack is a what attack? Suppose means the current literature solutions are saying whether the attack is benign or attack only. But once you identified attack, can you identify with your solution what specific attack type? Means is it a DOS attack or is it some sort of authentication attack or some sort of Mirai bot attack like that? Means using your solution, can you identify a specific attack type? Okay, towards that also we provided certain solutions that is called binary classification and as well as detect know the attack only specific attack. You have a doubt, sir, what is the advantage you will get by identifying the specific attack type? Because by identifying the specific attack type, I can provide a mitigation solution. If this attack happened, this is a way you need to stop it. Because the attack nature of attack type 1, attack nature of attack type 2, type 3, type 4 might not same. So that as the attack nature is not same, we need a different kind of solution for different attacks so that you're able to protect your IoT network properly. That's what my fourth research question is formulated towards this. Now, as I mentioned in my problem statement 1, okay, research question 1, whatever the traffic is generating and pushing to a gateway, here the gateway. Now we are unable to identify what type of traffic it is. The reason is that whatever the rules mentioned to stop the attack, it is like a predefined rules or vendor dependent or your IoT behavior is completely dynamic, unable to capture the dynamic behavior and make it the flow rules into that. That is a big reason. Means what we identified in the literature, they not focusing on the dynamic nature of the IoT device and install the dynamic rules so that if the nature changes dynamically, I am able to mitigate it. If the nature is not changes, I am able to forward your packet to the rest of the network. Means in order to do that, we required some sort of machine learning algorithm. Now for that, what we have done, this is a methodology what we have designed. Now these are the various, we have taken a standard IoT data set which is present in the internet. Now what we have done, these are methodology which primarily focused on that. Now whenever your IoT data is generating, your IoT data or any network data basically consists of two parts. One is called header and one is called payload. Okay. Now, but we are not bothering about payload. Means we are in my research issue, we are neither bother about confidentiality and authentication and as well as integrity. We basically focusing on network-based attack, network-based attack, which can be mitigated by taking the header fields into account. That's why now by using the standard IoT dataset, okay, we crafted a packets from the dataset and generated that particular traffic or crafted traffic from the specific IoT device. Suppose this IoT device 1, device 2, device 3, which I am circling here. Now we run using iperf command. Now suppose this is a large data set. Assume that we segregated. First 10 rows belongs to device 1, next 10 rows belongs to device 2, like and so on. But for example purpose, I have taken 10, but in real scenario, large volume of the traffic is going to come. Okay. Now that whatever the traffic is generating, because this traffic is a real-time traffic which is captured in a certain environment that was formulated as a data set. That's why we used a standardized or realistic IoT traffic and generated from individual devices. Now, from the traffic, we bothered only header field of the particular IoT traffic. That header fields we extracted. For example, you know that whenever the traffic comes, it is a transport layer header, maybe IP header, maybe link layer header. Now we have taken few fields from the each and every header. Using these particular fields, I can easily distinguish, okay, what type of attack is going to happen. That's why using the parsers concept, which support a P4 language, that we extracted the headers and we also extracted only few headers because I have not required all header information, because some of the header information is a common to IoT traffic and IoT attack traffic also, means benign traffic and attack traffic. Convert them into a digest form and push it to my machine learning model, which is present in the controller. So that the machine learning model take this particular packet features as input, analyze it and analyze it and come out with appropriate insight. Yes, if this particular header information having so and so fields, because my data set is saying that this is the way you are going to attack traffic is going to generate, this is the way benign traffic is going to generate. Now appropriate action rules are going to be generated dynamically and mitigate the particular flow rules. Now this particular idea, what we have done, very less number of people are demonstrated with hardware prototype. We have taken certain IoT device that is called Raspberry Pi. Generally, as I mentioned in my slide 2, every IoT device should be connected with the sensors. But here we are not connected physically with any sensor, but we have crafted sensor data generated from the individual IoT devices. Now we have taken 10 IoT devices and 11th IoT device will act like a gateway, right? And you can see here some of the IoT devices are marked with red color. Now these IoT devices job to generate the only attack traffic, because whenever you take a data set, you might have seen in the target label, you suppose assume that this is my target label. It is mentioned a benign traffic or it mentioned a attack traffic like that. What we have done, this specific attack traffic we have extracted and said that these 10 attack samples are going to generate it from device D1. Next 10 attack samples are going to generate device D3. That is the way we extracted or we wrote the customized Python programming, dynamically extract this traffic information and dynamically generated from the individual IoT device. Suppose another set of Python program we have written where the target label mentioned as a benign that can be generated from D2, D4, like and so on. So that these traffic which are generated, because I made this as a one network, in wirelessly, these devices are going to communicate to a gateway. Wirelessly, it is going to be communicated to a gateway. Now, gateway, as I mentioned, whatever the machine learning model we have developed, that is based on the decision tree, which can accurately classify whether the given traffic is a benign and attack and say that, yes, it is happened. Now, for demonstration purpose, we have conducted various experiments, but one of the experiment data I have shown here. For example, you can see in your previous slide, device D1, it is in a red color, means it is a malicious device. Means obviously it is going to generate large volume of the data. You can see here, you can easily evident that device D1 is generating 13,000 samples, whereas device D2 generate only 7,000 samples. No doubt device D1 is attack data, device D2 is a benign data. That was identified by the proposed machine learning model and able to classify generating the attack traffic and benign traffic that you can see here. Even you can see that what type of specific IoT traffic is going to generate it. Means it is generated a TCP data flow, and whereas here it is generating a 4000 TCP data connection. As it is a benign, maybe sending the proper traffic, it is a 4000, but whereas here wrong TCP connections are established, due to that large volume of the traffic is going to be generated. And even we have seen some of the IoT, you can see here before our solution and after our solution. See, this is this blue color line represent how your benign IoT traffic is going to be generated. Sometimes little bit high volume of traffic and low volume of traffic. But this red color line represent your compromised IoT device. The data traffic rate is going to be very high. Behind the 8,000 data samples are going to be generated in a particular amount of time. Then after that, what happened? It is very clear if the particular device is compromised, you're going to generate large volume of traffic. But we provided a solution at the gateway. Yes, even though one of the device is compromised, generating the large volume of the traffic, by using your solution, can you detect it? That's why you can see the green color. Now, when I introduce my solution, yes, I detected particular device is generating the large volume of the traffic, so that I have taken necessary action, drop further, not to generate or not to count or not to allow the traffic generated from the device. That's why once we identify, gradually we brought down number of devices forwarded from the attack traffic is 0. You can see in the green color here. That was tested in many iterations and provided this particular solution. Now, as I mentioned in the first research question, the subpart of the solution, can we identify the traffic which is generated? The previous solution, whether the benign traffic or attack traffic. In the second solution, what we did, okay, this attack traffic is generating, but this attack traffic is generating from which type of IoT device? Whether the smart camera device or medical device or from the certain smart home applications. Why? Because once that, suppose assume that the traffic is generating from your smart home device or healthcare device or smart CCTV camera. Because among these three type of IoT traffic, now smart healthcare solutions traffic is more important. Now, can I identify the type of IoT device and prioritize accordingly? Right? So that what will happen? Your healthcare data is pushed to the internet little prior to your compared with your smart home IoT device and smart CCTV camera. Because that's why you see here objective need an efficient mechanism to classify type of IoT devices accurately. Here also we have used more or less some sort of features of the packet. And here also we have developed the decision tree based approach. You can see here if the some of the features consider, you can see here flow duration, flow ratio, okay, which source port the packet is generating, which source destination port, because so that your model is what our contributions. You may have a question that, sir, you have taken a data set and simply develop the machine learning model. What is your new contribution? Obvious question. Now, but we have not only developed a basic machine learning model, but we worked on the optimization of the model, because here your solution not only detect what type of IoT device, how fast you are detecting the type of IoT device is a matter, because your IoT traffic is generating in a second or in a minute the large volume of the data, so that appropriate decision need to happen on time. Now for that, the basic development of the machine learning model is not sufficient. Now, even though basic development of machine learning model is there, we try to optimize the model so that it can be deployable and tested in a real-time environment and able to give the quick decisions which can real-time usage. And also we have developed further certain solution, but in the interest of time, because I need to devote certain 5 to 10 minutes for the question and answer, just I'm skipping many solutions we have designed. These are all part of my research publication. You can look into that. Okay, and another interesting part, anyway, this I will cover in my subsequent slide. Now, what I want to say that with what type of security solutions, because every audience which present for this particular session expected that what type of research issues currently I can explore. First thing, the many security solutions are going to be provided using machine learning. You can see from the recent literature, even 2020-25, most of the security solutions are designed by using a machine learning algorithm. But the major challenge for any machine learning solutions, the data sets. Because today, data set, only you have a handful data set which is available. And these handful data sets also capture IoT traffic or attack traffic very limited. Because that's why the first major issue, what in my opinion, availability of security related data sets means you day by day variety of data sets, variety of security issues are happening, but capturing that specific attack data sets are very limited. Now, what is present in your shoulder or what you need to be explored? You know that variety of attacks are going to happen. Can you make a small test bed like what we have created? Now, created data sets based on your attack type means you create an attack methodology, write a respective program which is related to that particular attack, right? And mimic that attack scenario with a few devices and capture that particular IoT traffic. That too, you capture the large amount of IoT traffic, either attack traffic or benign traffic, because when you want to train the model, the quality of data set is also a big issue. In the sense, you need the equal number of benign samples and equal number of attack samples, then only your machine learning model act or can be designed accurately. That's why first and foremost thing, you no need to work on the solution. If you're able to create a attack data set, that can be a good research contributions. Because wherever you go, just now I shown in my previous slide, only couple of data sets, right? 5 to 10. You take any recent research paper, even 25, 24, only those data sets are very popular. Now, as I mentioned in my just 1 minute ago, most of the machine learning models are developed in the low quality data. That leads improper machine learning model. It gives the inaccurate decisions. How to make your quality data is also very important. And augmentation of these particular IoT security data means what specific attack, these features related, that is also missing. That also someone can work automatic augmentation of IoT so that your learning capability is going to be improved. And another important is that suppose you develop a machine learning model, fine, whatever the data set available from the internet, you design a machine learning model, fine. That developed machine learning model you deployed into a device. But is this sufficient to mitigate the attacks? In my opinion, no, because the model which is trained by using one type of data set, the data lively generating is not matching. so that your machine learning model is not learned, then it might not take the appropriate decision. Now, can it be a lifelong learning of that? Means how do we ensure that? Because if you require lifelong learning means it required your model should train, keep train. But if keep training means training may not happen instantly, it required some amount of time. Either it should run in the cloud or then only training will happen. But the moment training required some amount of time, by the time your IoT attack data set generated, sample generated, you might not take the appropriate decision. That's why, how do we make the continuous learning so that any new attack type of data is generated also can easily detected with existing machine learning models. Okay, that's why some people are working on self-learning machine learning model, or some people are working on the transfer learning based machine learning approaches. Then some people even can look into that, how to provide a effective machine learning model by using these two approaches. Then another another emerging area which work on IoT and privacy of ML and DL models. Yes, you developed a model. Suppose assume that you developed a machine learning model by using a certain healthcare data. Then what will happen? That healthcare data collected with X patient, Y patient, or Z patient. That healthcare parameter values are private to him. Now you generated somehow machine learning model. Weights are deployed into a distributed manner to the edge devices. Suppose I am the attacker. There is a possibility you can extract the weights. Using the weights, you are able to generate your original data. So that if you're able to generate the original data, now using that original data, using some direct or indirect method, I can easily correlate, yes, this particular healthcare parameter related to whom. Suppose if it is related to a person one, so that indirectly I came to know your vital parameters. Means the privacy of ML and DL models is also under the attacker control. That's what I skipped a few slides that I'm going to discuss in my another session. That is also going to be important and active research is happening. Then another important research. Yes, you might have heard about edge computing. Now, whatever the machine learning model you have developed, now can it be deployable at the edge so that it can act on real-time data? Now, if we want to deploy these models in the edge, means it required resources. But in real scenario, whatever the IoT device present at the edge, in my previous explanation, I said that edge device can be a Raspberry Pi, but Raspberry Pi having decent resources, but not enough resources present here. But if I deploy a machine learning model into that, is these resources are sufficient? If not sufficient, you cannot enhance the resources because any hardware is proportionate to the cost. I cannot deploy 30 or 40,000 device at the edge level, but I have only Raspberry Pi worth of 7 to 8,000 rupees. But only solution you have, how do we optimize the model and deployable at the edge so that it can act on real-time data and take appropriate decisions? That is also active research is happening from the literature. And these are the various other which I mentioned in my previous slide. I am not going to reiterate. Like any machine learning model required huge resources, but other side it has a less resources and landscape means diversity of architecture, etc. These all another sort of research issues also which present in one research paper I brought. Now the conclusion is that the security and privacy is important problem in IoT because this is very less explored area related to IoT security, one can easily work on that. Any security solution, you name it, any application, or you can work on the specific IoT application, only healthcare or some industrial application. In that industry application, you can easily visualize it. What kind of security breaches when the data generated to the data stored? Many are there. Now you can visualize it. Yes, this can be a one security attack. First classify it is a network attack or data related attack. Okay, if it is a data related attack, how can we address it? Okay, if it is a network related attack, can it be addressed by using machine learning? Like that, many security solutions need to be designed, because IoT is going to be emerging and widely accepted technology. Now is the right time to work identify security issues and so on. And when you say the security issues, as I mentioned, it can be a device threat, or it can be a communication threat, or even service layers. In a software stack also, a lot of security issues are there. And as I mentioned, most of the IoT solutions are work on AI models. Now, but these AI models also under the attacker control. That is also one of the security threat. And as I mentioned, hardware-based and software-based attacks also possible, so that you can name it, any type of security attack is possible in IoT, but very limited solutions are present in the literature, in the recent research work also, somebody can. Now, ultimate aim, smart and lightweight security solutions are essential for the IoT environment, because IoT environment need a quick and faster decision. For that, optimized and smarter solutions are essential that can be worked out. That my final concluding statement is, the related to IoT security, somebody can pick up and work towards it, and you can provide a wonderful solution which can be used for the next generation. I'm stopping here. Thank you all. This is the contact details. My email ID is given. If anyone have any queries further, you can contact me. Thank you, sir. Thank you for giving me this opportunity to deliver a talk. I'm stopping here. Anyone have any doubt, they can ask me so that I can answer. Yes, please unmute yourself and ask. Anyone have any doubt? Okay, there's no doubt. I'm stopping here. Thank you all. Sir Venkatramulu, sir.
Sir.
Okay, sir. Thank you, sir.
Yeah, thank you very much, sir. Participants, dear participants, if you want to ask any questions, you can ask.
Anyone have any doubt, or if you're not able to ask them?
Ready to answer the queries. Yeah, thank you, Venkana sir.
Thank you,
for
sir.
Your wonderful
Thank you, sir. Thank you very much, sir.
On the IoT systems and security solutions. You given a wonderful session, sir, on machine learning, one of the solutions given for IoT security systems.
Thank you, sir.
Yeah, thank you very much, sir.
Okay, sir. Thank you. I'm leaving.
Yeah, thank you.